So today we're going to start on the binomial theorem. So a binomial expansion. Well, a binomial simply means two terms. And we're going to expand algebraic expressions out that involve two terms. There's the simplest one of them all. 1 plus x to the power of 0, which of course is 1. Then we go to the power of 1, and we get 1 plus, well, we don't normally write 1x, but I'm doing this for a reason, so it's 1 plus 1x. Then 1 plus x squared, which we know to be 1 plus 2x plus x squared. Then we looked at cubics. Now, if you can't remember how you get it, we could expand out 1 plus x times 1 plus x squared, and there we go. We get 1 plus 3x plus 3x squared plus x cubed. 1 plus x to the power of 4 then. Well, I could expand that one, 1 plus x times our last answer, and I get 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. There is a pattern emerging. Now, Blaise Pascal saw this pattern a couple of years before me and gets all the credit for it. Should be called Simmons's triangle, but anyway, that's okay. Because it wasn't Pascal anyway. Because the Chinese before him discovered it hundreds of years before him. Pascal gets all the glory. All right, there it is. 1. Here's the triangle. 1, 1. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. See the pattern emerging? 1, 5, 10, 10, 5, 1. That's a nice row, by the way. If you look at that one, I like that row. 1, 6, 15, 20, 15, 6, 1. Then, of course, you can keep going. That's got a nice feel about it. Yes, to 21 if I had to. That says 8. Ah, 9. Wow. Okay, you ready for this one? I think this row, personally, is my favourite. This is my personal favourite row. Ready? Da-da-da-da-da-dun. Watch this. 110, 45, 122, 10. 122, 10. How good's that? Palindrome in the middle, 252. It's a great row. You got to admit, that is fantastic. But, all right, we'll stop at 10 because it just doesn't get any better than that. So now, when you're walking down the street and someone stops you and says, oh, look, excuse me, have you got the time? And you say, oh, yeah, look, it's about 3:15 or whatever. Oh, good. Oh, and also, do you know what 1 plus 2x on 3 to the power of 7 is? And you'll be able to go, oh, yeah, yes, I do. Ta-da! Right? So, things that we notice in every term. The two powers always add up to be, in this case, 7. The powers of the first term, in this case 1, is going down by 1. The powers of the second term is going up by 1. And then, of course, you want to simplify that. Ta-da! And there it is. Doesn't that make life so much easier for expansions and rather expanding the whole thing out? Especially when the power's 21. Trust me. But here's where it's really useful, because let's be realistic. No one's going to walk up to you in the street and go, excuse me, what's 1 plus 2x on 3 to the power of 7? That's just unrealistic, okay? Don't know how to break the news to you. That's unrealistic. Let's have a look at a realistic problem. Right? Because you're in the street. Well, people aren't going to have a calculator on them. And so if they want to know what 0.998 to the power of 10 is to 8 decimal places, and they haven't got a calculator on them, yeah, what are they going to do? I've given you a bit of a hint there. Hang on. Instead of thinking of it as 0.998, we can use the expansion of 1 minus x to the power of 10, the best row of them all. 1, 10, 45, 122, 10, 252, palindrome. 2, 10, 1, 20, 45, 10 and 1. Because it's negative, the signs alternate. So plus, minus. But for x, all we've got to do is substitute in 0.002. Because 0.998 is 1 minus 0.002. But here's the really cool thing. I stopped at cubed. Why? Yeah, only need to do it to 8 decimal places. Well, 0.002 to the power of 4 to 8 decimal places is 0. So every term after that becomes 0. So whilst you thought you were going to be embarrassed in the middle of the shopping centre, no, you only have to work out a handful, and let's face it, they're pretty easy things to work out. 10 times 0.002. Move the decimal point, one place. 45 times 0.002 squared. Well, 0.002 squared would be point... How many zeros? Anyway, put it all together, and there you go, 0.980179904. You would say confidently to the person, and they would say, thank you very much, and they'd be on their way. Yeah? Maths, it's great. We're going to find the coefficient of x squared in this particular expansion, but the trick is I don't need to expand the whole thing out, because all I want to do is find the coefficient of x squared. So I know, yes, 4 plus 5x to the power of 4 would be some expansion, and there'll be a whole heap of terms in there. But I only want the ones that when I multiply it by the 2 terms in the other one, I'll get something x squared. So 2 would have to be multiplied by the term that has x squared in it. 3x would have to be multiplied by the term that just has x in it. And remember, it said coefficient, so I don't need the x's. So there's our answer. 2 times 6 times 4 squared times 5 squared minus 3 times 4 times 4 cubed times 5. Oh, you want a number? Okay. 960. 5A.